Hello everyone. We have been dealing with questions on the mall, and I actually posted a question paper which was having question number 27 up to question number 26. So far, we have answered question number 27 up to question number 32. We are remaining with question number 33 up to number 36. So far, I've posted the answers for question number 33, question number 30 up to question number 32, but I've not made a video on the same. Today, I posted question number 31 all the way up to question number 36. So a good student should go on to attempt all those questions before I make a video on the same, so that they may benefit. If a student does these questions, that student starts a very good chance to answer any question on the mall, be it a practical question, be it a theory question, maybe from paper 1 or paper 2 or paper 3. So I encourage the students to attempt before I make the video. So as I said, the student should attempt all the questions so that they can gain experience, be it on the mall, be it on energy changes. The student should do as many calculations as possible. So stay tuned. I'll be posting the questions, at least 3 questions per day, especially on the mall. Other areas will also do them with time. But specifically, the mall has been having a great problem with most of the students. That's why I've actually picked on this topic, so that we can do as many calculations as possible, so that the students can get more experienced or more practice, so that when it comes to KCSE exam, it will be very easy. So these questions will actually assist the Form 4s majorly, because they are almost doing the exam this year. The Form 3s can also attempt them, so that they can get more practice, they can get more experience and prowess to test their prowess and their experience. Question number 30. An organic compound P contains 68% carbon, 13.5% hydrogen, and 21.6% oxygen. The relative formula mass of P is 74. Determine the molecular formula. Carbon is equals to 12, hydrogen is equals to 1, oxygen is equals to 16. Now, to work out the molecular formula, we start by working out the empirical formula. So we start with the element. So the elements which are present are carbon, hydrogen, and oxygen. We write the chemical symbols of the elements. We follow by percentage composition. Carbon, percentage composition is 68.9. Hydrogen, percentage composition is 13.5. And oxygen, the percentage composition is 21.6. So you have carbon 68.5, hydrogen 13.5, oxygen 21.6. Followed by the molar mass. The molar mass of carbon is 12. So this 12 here is this 12 here. Hydrogen 1.0. So 1.0 is this one here. And then oxygen 16.0, which is this one. So these ones are the molar masses, or the relative atomic masses. We follow by indicating the number of moles, which is obtained by percentage composition divided by molar mass. Percentage composition divided by molar mass. So for carbon 68.5 divided by 12, we get 5.7083. I've written the answer to 4 decimal places. For hydrogen, it is 13.5, which is this one, divided by 1, which is this one. So what is on the top divided by what is on the lower side. Oxygen 21.6 divided by 16. 21.6 divided by 16. We get 1.35. Then we work out the mole ratio. We divide by the smallest. So which is the smallest between 5.7083, 13.50, and 1.35? So if you compare these 3 moles, you will get that 1.35 is the smallest. So for carbon 5.7083, which is the answer we obtained up here, we divide by the smallest, which is 1.35, we get the answer to be 4. For hydrogen, the answer on top, which is 13.5, we divide by the smallest, which is 1.35, we get 10. For oxygen, 1.35, we divide by 1.35, we get 1. So the empirical formula, you write the formula and the number of moles of that element. So for carbon, it is 4. For hydrogen, 10. For oxygen, 1. So this 4 is this one, this 10 is this one, and then oxygen, this one here is this one. So it can be the same as C4H10O, because this oxygen here, the chemical symbol indicates 1 atom. So how do you get the molecular formula now that you have the empirical formula? We'll say empirical formula mass multiplied by N should give us the molecular formula mass. So what's the empirical formula? C4H10O. We put into brackets N, should give us 74. So 4 times 12, we add, so 4 atoms of carbon times 12, which is the relative atomic mass of carbon, plus 10, which is the number of atoms of hydrogen, times 1, which is the relative atomic mass of hydrogen. We add 16, which is the relative atomic mass of oxygen, times 1, which is the number of atoms of oxygen. You multiply all this by N, should be equated to 74. So when you work it out, you'll get that 74N. So the total of this is 74 times N, we get 74N, should give us 74. We divide by 74, so N is equals to 1. So we write the empirical formula, we multiply by 1. So the answer is C4H10O. So for this compound, the empirical formula and the molecular formula are the same. Question number 31. Compass GAZ cylinder contains about 1.12 dm cubed of butane measured at 0 degrees Celsius and 1 atmosphere. 0 degrees Celsius and 1 atmosphere are the conditions at STP. So this one is the same as saying measured at STP. Given that 25% of heat is lost, what is the maximum volume of water at room temperature which can be obtained to which can be boiled to 100 degrees Celsius in order to make some coffee? Then the formula is C4. We have the formula, the equation for the reaction. Given that specific heat capacity of water is 4.2 joules per gram per degree Celsius, density of water is equals to 1 gram per cubic centimeter, molar gas volume at STP is equals to 22.4 liters, and room temperature is approximately 25 degrees Celsius. Now, how do we handle this problem? We start by calculating the number of moles of butane, which is equals to, we use the molar gas volume, 22.4 at STP. 22.4 liters is the same as 1 mole. So you'll come here and say, if 22.4 dm cubed is the same as 1 mole, what about 1.12 dm cubed? So we'll say, you do cross multiplication, 1.12 dm cubed times 1, we divide by 22.4. We get 0.05 moles. So that's the first step. We get the number of moles of butane using the molar gas volume. Then step number 2, we calculate the amount of heat released. We use the equation which is on top here. 1 mole of butane, when it is completely burnt, releases negative 2000 degrees kilojoules of heat energy. So you'll come here and say, if 3000 kilojoules is equivalent to 1 mole, in other words, 3000 kilojoules, which is this answer here, is equivalent to 1 mole of butane. What about now? The number of moles that we obtained here will release what amount of heat energy. So we'll say, what about 0.05? The answer we have got up here will release what amount of heat energy. So it will be 0.05, we multiply by 3000 and we divide by 1. We get 150 kilojoules or 150,000 joules. But there's something that we need to remember. We need to remember that 25% of heat is lost. So only 75% is used. So 75% of the heat which is used is 100 times the joules. So it will be 75% of 150,000. So the amount of heat that is released or that is used is 112,500 joules. So we are done with now the amount of heat which is released, or we are done with Q, or we are done with delta H, which is the heat change. So the heat change is 112,500 joules. We move to step number 3. The heat needed to boil the water from 25 degrees to 100 degrees Celsius. So what amount of heat is required? So delta T will be 100 minus 25. We need to remember this. We are boiling to 100 degrees Celsius, but we are not starting at 0. We are starting at room temperature. So it will be 100 minus 25, which is room temperature, the temperature that the water already has. So it will be 75 degrees Celsius, which is the same as 75 Kelvin. So we know that heat change, or delta H, is equals to MC delta T, or heat change is equals to mass times specific heat capacity times temperature change. So how do we make mass the subject of the formula? So we make mass the subject of the formula by dividing by specific heat capacity times temperature change. So mass is equals to 112,000, which is heat change that we obtained here, 112,500. We divide by C, which is 4.2 joules per gram per Kelvin, times now temperature change. And temperature change we said is 75. 100 minus 25 is equals to 75. So you get 357.14 grams. Lastly, that is step number 4. We convert mass to volume. We know that 1 gram, or the density of water, is 1 gram per cubic centimeter. The answer that was up here. So what about 357.14 grams will be how many cubic centimeters? So it will be, we do cross multiplication again. 357.14, we multiply by 1, we divide by 1. So the answer is 357.14 cubic centimeters, which is the same as 0.36 liters, which is the same as 0.36 dm cubed. 1 liter is the same as 1 dm cubed. So 0.36 liters is the same as 0.36 dm cubed. There's something that I would like us to check here to convert mass to volume. We know that 1 gram, density of water is 1 gram per cubic centimeter. Therefore, it means 1 gram is the same as 1 cubic centimeter. What about 357.14 grams? So we now do cross multiplication, or we can say if density is equals to mass over volume, what about mass? Then mass will be, what about volume, sorry? What about volume? Then volume is going to be mass divided by density, and we get the volume. Another very important note for the students: if the specific heat capacity of water is 4.2 joules per gram per degree Celsius or per Kelvin, then you have been told that when you're doing your calculation, you make sure that the specific heat capacity is in joules per gram per Kelvin. Then it means you are not going to convert the mass from grams to kilograms, because you are dealing with joules per gram per Kelvin. So this part of converting is not there. You cannot say M is equals to let's say the M, which was the mass, you don't convert to kilograms, because already the specific heat capacity is in joules per gram per Kelvin, or per degrees Celsius. Question number 32. An aqueous solution containing anhydrous sodium carbonate was prepared by dissolving 19.6 grams of the salt in 250 cubic centimeters of distilled water. Calculate the volume of 2 molar magnesium chloride solution required to precipitate all the carbonate ions in the solution. Sodium is equals to 23, carbon is equals to 12, oxygen is equals to 16, magnesium is equals to 24, chlorine is equals to 35.5. Step number 1, we write a balanced equation for the reaction between aqua solution of sodium carbonate and magnesium chloride solution. So the products are magnesium carbonate and sodium chloride. So we make sure that this equation has got the correct chemical formula, the correct state symbols, and correctly balanced. So after writing that equation, we realize that the mole ratio, the reactive mole ratio is 1:1. Remember, magnesium carbonate is a precipitate, therefore the state of the precipitate is solid. Step number 2, we find the moles of sodium carbonate. So moles is equals to mass in grams divided by molar mass. So the moles will be mass, which is 19.6, what we had up there, 19.6 which we had up here, this is the 19.6, we divide by molar mass of sodium carbonate, which will be 23, which is the mass of sodium, the relative atomic mass of sodium, times 2. This 2 here is the number of atoms of sodium, which is these two atoms of sodium. We add 12, which is the relative atomic mass of carbon, times 1, which is the number of atoms of carbon. We add again oxygen. The relative atomic mass of oxygen is 16. We multiply by 3. This 3 is the number of atoms of oxygen, which are these 3. So you get the molar mass to be 106. So the number of moles will be mass, which is 19.6. We divide by 106, which is going to give us 0.1849 moles. Again, I usually prefer giving the answer for the moles to 4 decimal places. Step number 3, we work out the number of moles of magnesium chloride needed using the mole ratio. So if this equation was not correct up here, we will not be able to get this correct mole ratio. So sodium carbonate to magnesium chloride, mole ratio is 1:1. So we don't assume that the number of moles are the same. What we are going to do, we are going to show that if 1, which is the 1 for sodium carbonate, is equivalent to this number of moles of sodium carbonate, if 1, the mole ratio of sodium carbonate, is equivalent to 0.1849 moles, what about 1 for magnesium chloride? So we do cross multiplication, which is going to be 1 times 0.1849, we divide by 1. And so you have said, what about 1 for magnesium chloride? So we'll do cross multiplication. We say 1 times 0.1849, and we divide by 1. And we get the answer to be 0.1849 moles of magnesium chloride. Now the volume of 2 molar magnesium chloride is our step 4. So we start by writing the formula whereby we say moles is equals to volume in cubic centimeters times molarity, we divide by 1000. So we make volume the subject of the formula. So volume in cubic centimeters will be number of moles times 1000, we divide by molarity, which is going to be 0.1849, which is the number of moles of magnesium chloride, times 1000, and then you divide by 2, which is going to give us 92.45 cubic centimeters of 2 molar magnesium chloride. This 2 is actually the molarity, and then we get our answer to be that. So the most important point that we need to consider here is that the equation must be correct. The equation must be balanced. The chemical symbols must be correct. The state symbols must be correct. If you are not in a position to write the equation, then everything is done. So you must learn how to write the equations. This one you get from the topic solved in Form 2. You learn how to write the equations and it will be okay.